In this video, we're going to talk about some different types of transformations, continuing on what we learned in class today. So for right now, I would like you to graph these four different equations. They're all based on your parent function x squared. This one should hopefully come from memory. For the others, I want you to make a table to find some critical points. Go ahead and pause and check your answers. Our four graphs should end up looking like. So we've got our parent function, and then you may notice that from this function to this function, our graph gets a little bit narrower. And same thing from here to here. Our function again is getting narrower and narrower as we put larger numbers in front of our parent function. However, as we put a smaller number in front of our parent function, we've got 1/2 in front. You may notice that this seems a little bit wider than the parent function that we originally started with. In this video, we're going to be talking about what happens when we multiply our parent functions by certain numbers and what that does to our graphs. In this video, we're going to be talking about stretching and compressing our parent functions. Stretching and compressing functions. So when we stretch a function, it's being pulled apart. So it's either being pulled apart vertically or horizontally. It's being stretched out to become taller or stretched out to become wider. And when we're stretching our functions, stretching our parent functions, this is by a factor greater than 1 when our function is being stretched. Our other option is that our function is being compressed. So in this case, it's being pushed together. So vertically, it can be compressed, where it's getting shorter and shorter, or it can be horizontally compressed, where it's getting thinner and thinner. When this happens, it's by a factor less than 1. So stretched by a factor greater than 1, compressed by a factor less than 1. Okay, so to give just a brief example, if I've got my original parent function x squared, if I'm stretching my function vertically, so stretch by a factor of, let's say, 2, it's going to get taller and taller, narrower and narrower. Or those key critical points are going to get taller from where they were originally. Okay? Versus if this is being compressed vertically, so this is being stretched vertically, if it's being compressed, let's say by a factor of 1/2, and again vertically, then my parabola might be getting wider and wider, where it looks something like this. It looks more like a bowl than like a U. So stretched vertically, it's getting taller. Compressed vertically, it's getting wider. Okay, let's look at a couple examples. It's really dark. Okay, so we're going to start off with this first example. So if I've got f of x equals the absolute value of x, go ahead and graph that parent function on your page. You need a couple of critical points. So you should have critical points at 0, 0, 1, 1, negative 1, 1, and maybe at 2, 2 just to get that V shape. Okay, and then the V in the opposite direction. Okay, if I am taking f of 2x, So this is the same thing as the absolute value of 2 times x. When I've got a value on the inside of my function, I'm taking my x values, so notice that I'm multiplying this x by 2. And I'm actually multiplying them with 1 over c, 1 over whatever that number is in front of x. So in this case, I'm taking my x values and I'm multiplying them by 1 over, and that value on the inside is 2. X is being multiplied by 1/2. Over at my critical values in my parent function, and I'm going to take each of my x values, so all of my values on my x-axis over here, and I'm going to multiply them by 1/2. So starting at 0, 0, well, my x value is 0, multiplying it by 1/2, I'm going to end up at 0. My next critical point, so my x value in this case is 1/2, or sorry, is 1. If I take 1 and multiply it with 1/2, I'm going to end up at 1/2. My y value, though, doesn't change. So in this point, x is 1, y is 1. My x value is going to change to 1/2, but my y value stays the same. It's still at 1. Let's look at our next critical point. So at 2, 2, I'm taking my x value 2 and I'm multiplying it 1/2. So 2 times 1/2, well, that's just going to give me 1. But my y value stays the same, so I'm going to go up 2. Okay, if I keep going, the next even number that I'm going to have is 4. So at 4, 4, if I multiply 4 by 1/2, I'm going to get 2. But then I'm still going up 1, 2, 3, 4. So one side of my v is going to look like this. If I do the same thing to the left-hand side of my graph, so I've got -1, 1. When I multiply -1 by 1/2, I'll get -1/2. My y value stays the same. This v is going to end up being symmetric. Okay, because I'm multiplying my x values by 1/2, this value, 1/2, is less than 1. So because of that, I'm going to be compressing my function f of x by a factor of 1/2. Well, if I think about what got compressed, whether it was my x values or my y values, my x values were the ones that changed. When your x values change, because your x-axis is your horizontal axis, so x is horizontal, y is vertical, because my x values are changing, my function is being compressed horizontally. So in this case, my function is being compressed by a factor of 1/2 horizontally. Let's look at another example. Okay, so again, I'm going to start off with my original parent function. We'll start off with the same one, just for some consistency. So if I've got f of x equals the absolute value of x, go ahead and graph that parent function from memory. What does it look like? Okay, your graph should match mine. Now if I'm taking 1/2 of my function, so 1/2 of f of x, which is the same thing as 1/2 times the absolute value of x. Well, in this case, I'm taking 1/2 and I'm multiplying it with f of x. Remember for a second that f of x is equal to what? Right, f of x is equal to my y value. So really, I'm taking 1/2 and I'm multiplying it by my y values. So I'm taking 1/2 times y. This time, I don't need to do any switching of my numbers. So I'm going to go ahead and set up a coordinate plane down below. And so this time when I'm looking at my critical points, I'm taking my y values and I'm multiplying them by 1/2. So I've got the points 1, 1, 2, 2, -1, 1, -2, 2. And this time I'm taking my y values and multiplying them by 1/2, where my x values are staying exactly the same. So for this first critical point, at 1. My x value is staying the same, but this time I'm taking y, which is 1/2, and multiplying, or 1, and multiplying it by 1/2. So 1 times 1/2, my new y value is just going to be 1/2. But this time again, my x value stays the same. If I look at my next critical point, 2, 2, my x value stays the same, so I'm going to go over to 2. But then I'm taking my y value, 2, and multiplying it by 1/2. This will give me a y value of just 1. If I do the same thing on the other side, so -1, 1, my x value stays the same. I'm taking my y value, 1, and multiplying it by 1/2, which will give me 1/2. 0, 0 is going to stay the same. Come up with a couple other points. What are some other points on this, or in this new function? Great, so at 4, I'm going to get to 2. And I'll have this kind of smushed v, where my slope, it's kind of like the slope of my two sides, is 1/2. Okay, again, because I'm multiplying my y values by 1/2, I'm compressing my function f of x by a factor of 1/2. But this time, what was affected was my y values. So this vertical axis is being affected. Since y is my vertical axis, this is being compressed vertically. It's as if I've got two kind of fingers and they're pushing at my ends and squeezing the graph to be shorter. We'll look at another example. So go ahead and start off with your parent function h of x equals x to the power of 3. What does your parent function graph look like? Graph it on your own. Okay, this is what our parent function h of x equals x cubed looks like. Now what if I take, we'll do f of x is equal to 3x to the power of 3. So this is the same as x to the third. Well, that's equal to h of x. So this is taking 3 times my function. So my 3 is on the outside. I'm taking my 3 and I'm multiplying with h of x. Well, remember, whatever this function is, that's equal to my y values. So in this case, I'm taking 3 and I'm multiplying them with my y values. Let's take a look at what this graph is going to look like. So I've got 3 critical points I'm going to look at: 0, 0, 1, 1, and -1, -1. At 1, or we'll start at 0, 0. So x stays exactly the same. And I'm taking my y value, my second value, and multiplying it by 3. 3 times 0 just gives me 0. So I'm still going to be going through my origin. Then I'm going to take 1, 1. So my x value stays the same. I still go to the right one. But now I'm taking my y value, 1, and multiplying it by 3. So I'm going to go up 1, 2, 3. And then my last critical point, -1, -1. So my x value stays the same. If I take -1, my y value, and multiply it by 3, I'm going to end up where? Great, at -3. Okay, so I'm going to keep this same general idea of my graph. It's just getting a lot taller, but still a little bit curvy, not exactly a straight line. What type of, is my function being stretched or compressed in this case? Okay, well, I'm multiplying by 3, or I'm multiplying my y values by 3. Because that value is greater than 1, this is going to be a stretch. And I'm stretching my function f of x by a factor of what? Since I'm multiplying by 3, it's going to be by a factor of 3. And is this affecting my vertical, the verticalness of my graph, or the horizontal? The vertical stretch or horizontal stretch? And this is being stretched vertically. Okay, let's do one more example. Go ahead and sketch your parent function of the square root of x from memory. What are your critical points? Okay, your graph should look like my graph. Now what if I'm graphing f of x equals the square root of 3x? When I've got a value on the inside of my parent function, what do I do with it? Okay, so I'm multiplying this value with my x, but instead of just a regular 3, I'm taking 1 over 3 times my x values. So remember, it's 1 over c, whatever that value is on the inside. Let's go ahead and set up a coordinate plane. So I've got my 3 critical points, 0, 0, 1, 1, and 4, 2. In this case, is my x or my y value changing? Great, x is changing, my y is staying exactly the same. So my x values are what are changing. Since I'm multiplying 1/3 with x, my y values are going to stay the same. So in this case, all of my y values 0, 1, and 2 are going to stay exactly the same, just the x values are going to change. If I take my x value 0 and multiply it with 1/3, 1/3 times 0 still gives me 0. If I take my x value 1 and multiply it with 1/3, 1 times 1/3, well, that gives me a third. But my y value 1 still stays exactly the same. Okay, and lastly, if I take my third critical point, 4, if I take 4 times 1/3, 4 times 1/3, well, that will leave me with 4/3, which is the same thing as 1 and 1/3. So I'm going to go to 1 and a little bit over on my x-axis to a third, and my y value stays exactly the same. I'm still going up 2. So this function is going to get a lot taller. So you'll notice it's getting taller, but it's also as if someone's pushing in on it horizontally. So my x values are what's changing. This means that I'm going to have a horizontal. Well, and since it's a 1/3, I'm multiplying by 1/3. Is this a stretch or a compression? Great, a horizontal compression of a factor, or by a factor of 1/3. If you're feeling a little lost with it, that's okay. Just make sure you come to class with questions tomorrow. We're going to go over one last piece of information that might clarify a couple of things. So just one last piece of notes to add on here. When you are doing these transformations, and this is kind of the final equation that you need to know for your transformations, you're going to have y equals a out in front times f of, and this might be a little bit different from last year. Rather than x minus h, we're going to have a c out in front, and then in parentheses you'll have your x minus h. And that all goes inside of your function, inside of your parent function. And then on the outside you've got a plus k. So remember from class we talked about h and k. H tells you about your left and right movement. K tells you about your vertical up and down movement. So you'll notice that when you're on the inside of your parent function, you're dealing with horizontal movement, and when you're outside of your parent function, you're dealing with the vertical movement. We just talked about, or dealt with, a lot of a and c values, which are the other two values that you need to know. If you've got an a value, or your a value is going to affect your vertical change. So you are going to have a vertical stretch, if a is greater than 1. A vertical stretch if a is greater than 1. You'll have a vertical compression. So one option is stretch, the other option is compression. If your a value is less than 1. Vertical stretch if a is greater than 1, vertical compression if a is less than 1. Your C value tells you your horizontal stretches and compression. So you're going to have a horizontal stretch. And remember, this is kind of the weirdo one, similar to H. You're going to have a vertical stretch if 1 over C, so not just C, but 1 over C, is greater than 1. A horizontal stretch if 1 over C is greater than 1. Or you'll have a compression, a horizontal compression, if 1 over C is less than 1. For both of these, you want to know how to find that factor. So you'll have a vertical stretch or compression by a factor of A, whatever that value out in front is. So it would be a vertical stretch by a factor of A or a vertical compression by a factor of A. Versus for your horizontal stretches and compressions, this is going to be by a factor of 1 over C. So similarly to how all of these values are 1 over C, your multiplication factor is also by 1 over C. So what each of these statements mean, if you've got a vertical stretch or compression by a factor of A, you're multiplying all your Y values by A. Multiplying all of your Y values by A. Versus with a horizontal stretch or compression, you're multiplying all your X values by 1 over C. Multiplying all of your X values by 1 over C. And then just one last piece of, or one last summary. So we've got two options when it comes to vertical stretches or horizontal stretches and compressions. So you can either be vertical or you can have a horizontal stretch or compression. With a vertical stretch or compression, the value is going to be outside of your parent function, on the outside of your parent function. Vertical stretches and compressions affect your Y values. So really what you're doing is you're taking your Y times A. So your vertical stretches and compressions are coming from your A value. Versus in a horizontal stretch or compression, it's coming from the inside of your parent function. This is your C value. Your horizontal stretches and compressions are going to affect your X's, your X values, and really what you're doing is you're taking X times 1 over C. And I might put just a star around 1 over C so that you remember that that value doesn't stay the same. And this last chart will be helpful for tomorrow. Come with any questions that you have.